All right, so now that we've done that, we are going to do some algebra practice with the kinetic energy equation. All right, so let's go ahead. We'll do 1/2 kinetic energy equals 1/2 mv squared. All right, so when you do different word problems, you're going to have different pieces of information. Let's start off with a problem where we know the mass of the object and we know how fast it's moving. For example, we can have a car that weighs that has a certain mass, and the car could be moving at 4 meters per second. So then we can plug in the mass of the car, how fast it's moving, and very easily plugging this into a calculator, find out the kinetic energy of the car. Okay? But let's say it's not so simple. Let's say we know the kinetic energy of the car, and we know how fast the car is moving, but we want to find out what is the car's mass. Okay? So if we know the energy it has and we know how fast it's moving, all we need to figure out is how many particles are in the object, how much mass it has, in order to know all the information. Okay? So in order to solve, we're going to have to get mass m by itself. Now, whenever we're trying to get a variable by itself, there are two things we need to do. We need to get the variable in the numerator, and we need to get the variable alone. Okay? Right now, our m is in the numerator. Okay? So if your variable is in the numerator, you don't need to move it at all, right? Because it is where it's supposed to be. However, if the variable is not alone, then we need to get all of its friends away from it. Okay, so right now, mass has a lot of friends hanging out, but it needs to be alone. So all of its friends have to leave. Okay, so the first friend to go is this fraction. It's sometimes easier to get rid of the numbers before getting rid of the variables, the non-numbers, right? And so in order to get rid of a fraction, what do you think we're going to do first? All right. So in order to get rid of a fraction, we are going to multiply by the reciprocal. Okay? I'll write that down in case you haven't heard of it before. The reciprocal is when you flip a fraction. So if the fraction is 1/2, the reciprocal is going to be 2/1. Okay? If the fraction is 3/4, the reciprocal is going to be 4/3. So the reciprocal is just when you flip the fraction. Now, the reason we multiply by a reciprocal is because when you multiply, for example, 1/2 by 2/1, we end up with 1 times 2, which is 2, over 2 times 1, which is also 2. And now my fraction is equal to 1. And so I can essentially cancel out the fraction by multiplying it by its reciprocal, because it'll then equal 1. All right, so let's go ahead and do that here. So I'm going to multiply 1/2 by 2/1. And whatever I do to one side, I need to do to the other side. So I have to multiply the kinetic energy also by 2/1. Now again, 1/2, I have 1 times 2, which is equal to 2. And then I have 2 times 1, which is equal to 2. So these are going to cancel each other out and just equal 1. So I end up with 1 times mv squared over, now this is 2 times ke, because both of these are in the numerator. And 1 is the only thing in the denominator on this side, so I still have 1 in the denominator. Now, if we want to simplify this equation a little bit, we can. So 2 times the kinetic energy divided by 1 is going to equal 2 times the kinetic energy. Anything divided by 1 is itself. So I can actually erase that divided by 1 and just leave it here. Now, anything multiplied by 1 is also itself. So 1 times mv squared is also just mv squared. Great. So now I'm this much closer to having m by itself, having m alone. Now, m is still hanging out with another friend, v squared. So it's time for v squared to leave and go home. In order to get v squared away from m, I need to figure out what is holding them together. Now, again, like we mentioned earlier, if you don't see an operation between two variables, you assume that the variables are being multiplied. So, assuming multiplication, I want to do the opposite operation in order to separate both of the variables. So if multiplication is happening, I want to do division, okay? And now I need to figure out what I want to divide by. Well, the only thing being attached to m is v squared, so I'm going to divide by v squared. And when I have something on the top and something on the bottom, then I can actually make that equal to 1. So that means m times v squared over v squared, which is m times 1. All right. Now I also have to multiply this side by, I have to divide this side by v squared as well. So that's going to be 2ke divided by v squared. Okay. So, again, the reason I did that is because whatever you do to one side, you have to do to the other side. So let me actually show you up here in this stage. That's where I first do it on both sides. So now I have 2 times the kinetic energy divided by the velocity squared equals m times 1. And again, anything times 1 is equal to itself. So we can just erase that. Now we have 2 times the kinetic energy divided by v velocity squared is equal to the mass. All right. So if I needed to find the mass of the object, I could go through this process, and now I can calculate the mass. All right. Cool. Now, let's go ahead and try to figure out how to find the velocity. Okay. So I'm going to go ahead and erase everything on both of these sides. Now we're back to our original equation. So let's say we know the mass of the car and we know how much energy it has, but we don't know how fast it's moving, okay? In order to figure that out, right, the last piece of the puzzle, we know it has to be moving a certain speed in order to have kinetic energy, but we don't know how fast it's moving. So in order to understand everything about the situation, we're going to have to solve for v, the velocity. So I find myself in a similar situation where the first step is to get velocity in the numerator. Now, the velocity actually is in the numerator, right? We know it's not in the denominator because just like we can tell with the 2, if this v were in the denominator, there would be a division sign above it. But there is no division sign above it, so we know it's in the numerator. All right? So since velocity is in the numerator, I don't have to move it. It is where it's supposed to be. But it is not alone. It is hanging out with its friends, so we need all of its friends to go home so that we can figure out what v is equal to. So first step again is to multiply by the reciprocal. All right? Because 1 times 2 is equal to 2. 2 times 1 is equal to 2. So that is all just going to equal 1. So I'm going to end up with 1 times mv squared. All right. But because I multiplied this side by 2 over 1, I have to also multiply this side by 2 over 1. And that gives us 2 times the kinetic energy, all divided by 1. But anything divided by 1, we can keep it as itself. It doesn't change. And then anything multiplied by 1 does not change. So we are now here. Now v squared is still hanging out with its friend m, mass, and they are being held together by multiplication, right? Because we don't see any operation, we assume it's multiplication. So we have to do the opposite of multiplication, which is division, and we're going to divide on both sides. And we need to get v by itself. We need to get it alone. So m has to go home. So m, we divide by m on both sides. Okay? So again, we can say m cancels out, right? We have m up top, m on the bottom. We can cross them out. Or, like we explained before, m divided by m is the same thing over the same thing, which equals 1. Okay? So now we have 1 times v squared, which is equal to 2ke over m. All right? So anything times 1 doesn't change at all. So v squared times 1 is still going to equal v squared. But the velocity is a little tricky. So we thought we got the velocity by itself here, but it's actually not quite by itself yet because it is still being squared, all right? So in order to truly get the velocity by itself, we also have to get rid of it being squared, okay? Now, in order to get rid of a squared, we have to take a square root, okay? So we are going to take the square root of v squared and the square root of the other side. All right? So the square root of the other side is 2 times the kinetic energy over m. All of that is in the square root sign. And when we take the square root of v squared, we get v. All right? And that is our final answer. All right? So great job. Hopefully that clarifies some things for you all, how to manipulate and change the equation to find the velocity or to find the mass. All right. These are the ways you want to go about doing it. To answer a question that some folks may have, in this step, some people may have thought you should divide by v. That also would get rid of the squared. But what that ends up doing is we would have to divide by v on this side as well. And now our v is not in the numerator, it is in the denominator. All right, so we want to always keep the variable we're looking for in the numerator. So if we divide it by v, we have to put it in the denominator, and that's not going to help us. All right, so great job. I'll catch you all later.